Now we're going to start looking at writing equations of lines when we're not given either M or B. We're not given either one, we have to find them both. Your first job is to find M. So what this problem is saying is we have 2 points and there's a line that goes through those 2 points. So to figure out the slope, the first thing we're going to do is we're going to, well, you guys already know how to figure out the slope, but the method I like to use is to do the loop-d's. So we set up the point. Notice it says -2, -1, and I go in that exact same order on my table. And then 3, 4 in the exact same order. Remember to find the slope, we do our loop-d's. How do you get from -1 to 4? You add 5. And to get from -2 to 3, you add 5. We always take our y loop-d divided by the x loop-d. So we have 5 divided by 5, m equals 1. Now if you don't want to do that, you could do the subtraction fraction, which says take the second y value minus the first y value over the second x value minus the first x value. One of the reasons I don't like doing that is because with all these negatives going on, people make mistakes, or they go in the wrong order and they end up with wrong things. So I would prefer that you use the table and the loop-d's, but either way, as long as you do it right. So we found that m equals 1, so we can write y equals 1x plus b. Now once again, we need to figure out what b is, so we're going to use a temporary solution. In this problem, we have 2 of them. We have the -2, -1, and we have the 3, 4. You can pick either one to be your temporary solution. Sometimes some are easier than the others. I'm going to pick the 3, 4. So I put 4 in for y and 3 in for x. Do my math, so 1 times 3 is 3 plus b, subtract 3 from both sides, 1 equals b. So my slope is 1 and so is my y-intercept. Y equals 1x plus 1 is my answer. So let's try another one. This would be a good time for you to hit pause and try and do it yourself. Here we're looking at our 2 points being 1, 5 and 4, 2. So I set up my table, 1, 5, 4, 2. Do my loop-d's. Here I subtract 3. Over here I'm going to add 3. So we get -3 over 3, which is -1. So my slope is -1. I plug that in for m. Again, I need to figure out what b is. I'm going to use a temporary solution, so I plug in 2 for y, 4 for x, plus b. 2 equals -4 plus b. Add 4 to both sides. 6 equals b. So y equals -1x plus 6 would be the equation for that one. Now, you see here that I have this word rate of change. Now, rate of change is just another way of saying slope. But when you hear the word rate of change, it's because we have a word problem going on. We actually have a situation happening. So to find rate of change, we put on top what's changing. So maybe it's talking about how many bunnies there are, or how many people there are, or how many mosquitoes there are. But what's changing and by how much over the change in time. Time is almost always your x value. And so when you are trying to figure out rate of change, the bottom, remember the bottom is the x loop-d, is going to be your change in time. So let's look at a word problem here. So it says in 1984, Americans purchased an average of 113 meals. So we have 1984 gave us 113 meals. By 1996, so I'll write that down, 1996, the number was 131. Write a linear model, this just means y equals mx plus b, for the number of meals or snacks purchased per person annually. Then use the model to predict the number of meals or snacks that will be purchased per person in 2006. So, remember how I said that time is usually your x value, so then the number of meals is going to be my y value. So I can set up a table here. We have 1984 and 113, 1996 and 131. So then as I look at this, from 113 to 131 is 18. From 1984 to 1996 is 12. So my slope is going to be 18 over 12, which reduces to 3 over 2. So I have y equals 3 over 2x plus b. Now b is going to be our interesting one. let's see here. Normally, I would say that B needs to be the place you started. So if we look at this, we started in 1984. And we got 113. So what we're going to do is we're going to plug in 1984 in for X and 113 in for Y. So we're doing our temporary solution. So 1984 plus B. Do some more math here. 113 equals, let's see, 3/2 times 1984 gives us 2,976 plus B. Subtract 2976 from both sides. So then we have 113 minus 2976 gives me a negative 2,863. So that is my y-intercept. So we have y equals 3/2 x minus 2863. And then we answer our next question. Use this model to predict the number of meals in 2006. So we are plugging in then 2006 for x. So y equals 3/2 times 2006 minus 2863. And you take your 3/2 times 2006 minus 2863, and you should get 146, which means you would have 146 meals in the year 2006. The other half of our lesson for today is direct variation. Now, we talked about this when you were in Algebra 1. There's 4 things to think about when you hear the word direct variation. The y-intercept is 0, which means when you graph the line, of a direct variation, you are going to be going through the origin. So if I draw this out, every single direct variation that I could graph is going to be going through the origin. All of these are direct variations. They would all intersect at the origin. You use the phrase y varies directly as x whenever you talk about direct variation. So if you ever see that phrase, you know you're talking about direct variation. And if you have where the y-intercept is 0, that means for your equation it's plus 0. And so a plus 0 doesn't add anything, so we don't need the plus 0. And so the equation that we have is y equals kx. Notice, instead of an m, they put a k there, and that's just to be silly. It actually goes back, I think, I've been kind of trying to research this, but I think it goes back to the Latin word for slope. But anyway, in physics we use direct variation a lot, and they replace the m with the k. It still works exactly the same way. So let's look at a problem that talks about this. The variables x and y vary directly, so that tells me right away I can write y equals kx. That should become an automatic for you. If you hear the words x and y vary directly, then you should write y equals kx. Now when it says that y equals 12 and x equals 4, they're saying you have this as a solution and this is a temporary solution. And the reason you're given that is because if you plug in 12 for y and you plug in 4 for k, all of a sudden you can figure out what k is, divide by 4 on both sides, 3 equals k, and now we know what our slope is. Our slope is 3. So we can write y equals 3x. So our temporary solution was 412. We plugged it in and we got our slope. So we actually did A already, write an equation. We did that using our temporary solution and finding k. And now we're supposed to find y when x is 5. So I'm going to take 5 and I'm going to plug it in for x. So y equals 3 times 5. and I get 15, so y equals 15 when x equals 5. Now this next part, I'm just showing you that y equals kx. If I were to divide both sides by x, which is completely legal, you'll notice then I'm left with just the k. And so if you want to quickly simplify it, k equals y over x. Now think about the subtraction fraction. When we do subtraction fraction, we take the two y values subtracted over the two x values and subtract them. So the y goes on top, the x goes on bottom. If you look here, y goes on top, x goes on bottom. So you have a shortcut. However, I would rather just look at temporary solutions when we do this. So again, we have another problem. The variables x and y vary directly. This is a good time to pause me and try this problem on your own. Y equals 15 and when x equals 3. So again, we have a temporary solution. So because I saw the words x and y vary directly, I write y equals kx. I can plug in my temporary solution. 15 equals k times 3. Divide by 3 on both sides. And 5 equals k. So y equals 5x is my answer to A. It's my equation. Then we look at B. Find y when x equals 9. So we plug in 9 for x. 5 times 9 is 45, so y equals 45 is my answer. All right, for our last set of problems here, we are supposed to tell whether the data show direct variation. So we're supposed to decide, is this a direct variation? So remember what we said, k is the y value divided by the x value. So for A, let's just focus on A right now. I'm going to take, for each one of these, I'm going to take the y value divided by the x value. So we have 12 divided by 3 is 4. Then the next one, 24 divided by 6 is 4. The next one, 38 divided by 9, and if I check that into the calculator, 38 divided by 9 is 4.2. And then we try 50 divided by 12. It's not exactly 4, it's 4.16. And then we have 65 divided by 15. Gives me 4.3. So now we have to decide, is this a direct variation? Now we have to look at this data and say, okay, is it exact enough or not? Is it close enough to 4 or not? You know, a lot of times real data isn't going to be exactly 4 every single time, but is it close enough? Now, we don't really know where this came from. We could technically say that this is not a direct variation because we have a few of these here that have an extra decimal onto it. Or we could say, if allowed for a little bit of variation, yes, this would be a direct variation. It all just kind of depends on where you get things from. If you're going to answer a question like that, like I just said, yes it is, no it isn't, make sure you just do a little more explaining than just saying yes or no. Actually say, well, I could say yes because they're all really close to 4, or I could say no because they're not all exactly 4. So now let's try B. Remember, we're going to take y divided by x. So I'm going to take 2.4 divided by 8, and I get 0.3. Then I take 4.8 divided by 16, and I believe I get 0.3 again. Yep. Then we take 7.2 divided by 24, and we get 0.3. Then we take 9.6 divided by 32, and we get 0.3. And last but not least, we take 12 divided by 40, and we get exactly 0.3. So I'm going to say yes, this is definitely a direct variation, and k equals 0.3 according to my calculations. Every single one of them was 0.3, so we can be very sure that what we're saying is a direct variation. So the equation for this would be y equals 0.3x.